Hi everyone, welcome back to Data Science in Your Pocket. And we have a new architecture released for LLMs that is Kimi Linear, which is performing better than Transformers and looks to be a big breakthrough. Basically, it uses linear attention rather than the general attention used by Transformers and other LLMs. New LLM architecture better than Transformers. So in this short video, I will try to explain what does Kimi Linear do, what changes are there in terms of mathematics, and how it is different from Transformers architecture. So let's get started. So first of all, let's understand why traditional transformers choke on long context. I think it has been a long hanging problem. If your context increases, the computation goes exponentially high. Quadratic scaling. Computation grows at square of sequence length. KV cache bloat happens. Inference slows down a lot and workarounds are required. If sequence is 2x, computation goes 4x. This is the problem. This is because attention scales quadratically. Because what happens for attention, it would be looking at all the other words present in the input. Hence, it scales quadratically. It's not linear. And hence, it starts choking when the context length is huge. What does Kimi linear architecture does? It is introducing multiple things. It is introducing linear attention, which has a complexity of O of n rather than n square. It has fine grained gating. That means it has a channel wise forgetting also. So it doesn't need to remember everything. Whatever is unnecessary, it forgets. It is very similar to if you remember LSTMs, where forgetting happens. It has a hybrid structure. It is just not using linear attention, but a combination of linear attention with full attention too. That is a ratio of 3 to 1 as we would be discussing. Fine grained forgetting, a closer look. As you can see here, it has a selective memory decay. So in case of transformer, what will happen? It stores all the intermediate text. Every text, the information would be stored and attention would be calculated. In case of Kimi linear, that won't happen. It would be forgetting certain words that are not necessary, will keep up only the important ones. The core idea, attention that behaves like a memory. It has a running memory state. So as you are passing through the input, what happens actually, it's not maintaining attention for everything, but it is remembering the important stuff, forgetting the things that are not required. Learnable forgetting, channel wise forget gates are present. Forgetting is a new positional encoding. So it also doesn't use positional encoding, which is used in transformers, the traditional transformers. So it doesn't remember the position using position encoding, but as you can see, no explicit encoding is required. Position and forgetting curve. So basically, within the memory only it is able to remember the stuff. So no positional encoding is required. Hybrid architecture, as mentioned, it maintains 3 is to 1 ratio. That means with for every 3 kDA, that is Kimi delta attention, that is called as a linear attention, they are naming it as kDA, one global attention layer is used. So when 4 layers are used, one global attention layer is always present. So the remaining 3 kDA layers would be helping you to minimize the computation, while the final global layer would be helping you to not forget the important information too, so that you don't miss out on anything. Hardware and implementation, I think it's efficient GPU parallelization, half region stability is there, open source kernel and hardware design is there. As you can see, optimized diagonal plus low rank structure is used. We won't be jumping into the details, but because of this the speed has increased by 2 cross. How it performs, it is giving great results on general reasoning, be it MMLU, BEH, Trivia QA, be it on GSM 8, AIME, on math and coding as well, long context task, and RL fine tuning is also improved. The results are great compared to traditional transformer. A small example to understand, as you can see here in transformer, if you get this particular sentence, you would be maintaining all the vectors for all the text, but in case of Kimi linear, you won't be doing that. You would be remembering just the important stuff. What does it mean for developers? Key benefits for long context system, that's more important. No data chunking is there, full corpus in memory, reduced GPU cost and predictable latency is there. Production ready integrations are there. Multiple applications, code interpreters. It's very important because code bases are huge, document agents, data analysis, long form content, and whatnot. Kimi Linear can be your go to solution. Key takeaways: it is better than transformers, built for long context, efficient memory usage, and open source and production ready. You should start using and exploring Kimi Linear too. It's a great architecture that the team has introduced. Thank you so much. I hope you try out Kimi Linear.